Okay, so for a 5, we want to match it up with one of the graphs A through D. And to make it easier, we'll just do the transformation. So from 0, 1, and 1b, in this case b being 4, and so I have the 4 right there, the only parameter that affects this graph is h, which is 3. So that's why you have x plus 3 right here. So then that becomes 3, 1. And then 3 plus 1 is 4, 4, 4. So if you look at the 4 graphs, this is the exponential growth, so it's either A or C, and the one that goes through 3, 1 and 4, 4 is letter C. Alright, so for number 10, they want you to graph it by hand, identify asymptotes, intercepts, and determine whether the graph is increasing or decreasing. So with the reference point 0, 1, and 1, comma, and the 1b, the base being 0.3, we know that this is a exponential decay or decreasing graph because the base is between 0 and 1. 0.3 is between 0 and 1. So we graph the points 0, 1 and 1.3 approximately right here. There's a horizontal asymptote here because k is 0. And so the graph will go something like this. Okay? So the horizontal asymptote is y equals 0. And the only intercept it has is a y-intercept. So the y-intercept is 0, 1. It does not have an x-intercept because there's an asymptote, a horizontal asymptote. And then what else? The function is decreasing. Remember, when you read a graph, you always read it from left to right. And so from left to right, the graph is going down, 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 down forever. Okay, so it's a decreasing function. Alright, 15. The reference points, again, this is exponential function. So the points are 0, 1, and 1b. In this case, the base is e. So, and the only transformations here, a is -1 and k is +3. So a and k affect only the y, and that's why you see above the y coordinate, you see -y plus 3. H is 0 and b is 1. Okay? So, that's my Pandora for that. And so now we're going to change. The x's do not change, and then the y -1 plus 3 becomes 2. The x does not change, so negative e plus 3, that's like 3 minus 2.7, so that's going to be approximately 0.3. Okay, so we're going to plot the graph. Okay, so we draw the horizontal asymptote at y equals 3. Plot the point 0, 2 and 1.3, so again approximately right here. And that's all you need to connect the points. Okay, and they're just asking for, it says identify any asymptotes of the graph. So this would be a horizontal asymptote at y equals 3. So for number 20, here's the table. I wrote it vertically because it gave me more space to write the work for A. So we're using PERT, the principal times e to the RT, because it's compounded continuously. So for rate, remember, you move the decimal 2 places to the left. So if it's 3%, it's going to be 0.03. Okay, and then in parentheses is the time. Okay, the time that you're going to be investing this money. So just plug it into a calculator. If you want, you could simplify this first, before you plug it in, so that way it's less keystrokes when you put it in, okay? Okay, so for 20, as you can see, I went through and I input everything on the calculator, and those are the values that you get. So there's really nothing to show other than, okay, I input this into the calculator, and those are your values. For number 25, you have to convert from logarithmic to exponential or vice versa. So 25 is a logarithmic equation, so now you have to convert it to exponential. So base, you look for your base, and in this case the base is 64. The exponent is 1/6, because remember the exponent is always on the other side of the log, on the other side of the equation of the log equation. So wherever you see log, you go to the other side, and that's your exponent. So this would be 64 to the 1/6 equals 2. So the sixth root of 64 is 2, is what this is saying. Okay, number 30 is also a logarithmic equation, and we're going to convert it to exponential. In this case, the base is e, so we're going to say e to the 1.6094 power equals 5. So for 35, they want you to evaluate the function without a calculator. So for 35, x is 1/4, and that is why I put it here. Okay, and then it said f of x equals log base 4 of x, so I replaced the x with 1/4. So 4, remember this means, well, I could write 4 like the 1/4 like this. I could say log, log base 4 of 4 to the negative 1, that's 1/4, right? So this -1 becomes a coefficient of the log, and so I'm left with -1 times log base 4 of 4. Well, log base 4 of 4 equals 1, so this part equals 1. So 1 times -1 is -1. Alright, for 40, base is 10. Log, when in your book it does have the 10 there. I didn't write it because it's the same thing. And you could see the h is -2. That's why you see x minus 2 right here. The k is -3, and that's why you see y minus 3 right here. So we transform the 2 points, and you get 1 minus 2 is -1, 0 minus 3 is -3. Then 10 minus 2 is 8, and then 1 minus 3 is -2. Okay, so we're going to sketch that. Okay, so we have the vertical asymptote, because h is -2, the vertical asymptote, because remember for logarithmic equations you have vertical asymptotes, not horizontal. So it's going to be at x equals -2, and then the points are -1, -3, and 8, -2. So approximately right here. Okay, and so let me just extend this a little bit more, and it goes something like this. Now it's going to cross. Don't think that it has a horizontal asymptote at the x-axis. It will cross the x-axis at some point. Over here somewhere. It's going to cross the x-axis. So for this one, they want you to give the domain, vertical asymptote, x-intercept, and sketch it by hand. Okay, so we already did the sketch part. So the domain would be x such that x is greater than -2, and then the vertical asymptote is x equals -2. The x-intercept, that would be where it crosses, the x-axis. So that means that y would be 0, right, at that point, wherever it crosses. So we're going to replace f of x, so I'll do the work right here. So f of x would be 0, log of x plus 2 minus 3, oops, not equal, but minus. So we're going to add 3.
You ready to save up to 90% off Swarovski jewelry? Then head on over to Chic Market.
That's free Pandora. Sorry. So log of x plus 2 And to solve for x, we're going to have to change it to exponential because right now it's in logarithmic form. So base is 10, so it's 10 to the third equals x plus 2. So 10 to the third would be 1,000 equals x plus 2. We're going to subtract 2. So 998. So the x-intercept, so there's no way I'm going to show it on this graph, right? Because the x-intercept would be 998, 0. So 45 is another logarithmic equation they want you to graph. So the reference points are 1, 0, and b1. In this case, the base is e. And the only parameter here is affecting the graph is k. K is positive 3, so y, we're adding 3 to all the y's. So we'll end up with 1, 3, and 2.74. Okay, now we're going to sketch it. So the vertical asymptote, since it did not translate left or right, the vertical asymptote is, oops, change the color, is right here at x equals 0. The points are 1, 3, and 2.74. So approximately, let's see, 2.7 about here. And so it's going to go like that. Okay, so they're also asking you for the domain, vertical asymptote, and x-intercept. So the domain is all x such that x is greater than 0, not equal to, sorry. The vertical asymptote is x equals 0. And for the x-intercept, we replace the f of x with 0, natural log of x plus 3, subtract 3, so that's going to give us natural log of x equals negative 3. And so to solve for x, the base is e, the exponent is negative 3, so it's e to the negative 3 equals x. You put that into a calculator, and it's approximately, that's not the approximate, sorry, x is approximately equal to 0.05. Okay, now on my graph it's not, it's not very accurate, it's right here. It should be closer to the y-axis, but again, it's just freehand, so that's why, when you draw it by hand, it doesn't come out exact. And then to sketch 0.05, it'd be hard to distinguish one spot from another, especially with a thick marker. So, but this is the numerical x-intercept. So that's where it would be. Let me just write it. So the x-intercept would be 0.050. So that's what it would be. Okay, so number 50 gives you the formula for, let's see, for the time that it would take someone to pay off a home that's worth $150,000 at 8% interest when the monthly payment is X, and in this case X is $1,254.68. Okay, and T would give you the time, the number of years that it would take you to pay that off. Okay, it's a very old problem because you don't find homes worth $150,000 anymore. But anyway, so I replaced the X with the monthly payment here and here. Then I simplified, and I got the denominator is now $254.68. And after this step, it's just calculator. You input this number times natural log of this ratio. And when you do that, you get approximately 20 years. That's for part A. For part B, they want to know the total amount paid over the term of the mortgage with a monthly payment. So we're assuming that the interest rate is going to stay at 8% the whole time, and that the